My name is Jody Clark. I'm with VMware Network and Security Business Unit. I'm a senior NSX systems engineer, and I wanted to give you a quick overview today of NSX and VXLAN technology, or what we like to call an NSX-101. So let's start out by taking a look at separating our network into physical and logical space. All right. So I like to equate NSX kind of like with vSphere with a hypervisor. All right, what does a hypervisor do? It allows me to take a single server down here in the physical space and then run lots of VMs on top of that. And then I use the hypervisor to control north-south access to the physical resources, memory, CPU, network I/O, whatnot, as well as to manage these VMs that exist in logical space. So NSX is much the same, right? We're going to take our physical network, and that's going to be pretty fixed, pretty standard, but we're going to build logical networks up here in this logical space and then just use that underlying fabric, that underlying network, to deliver the services that our logical network needs. So how does that look? We'll start out with a pretty typical three-tier hierarchical design. So we're going to have a core network device, some sort of distribution layer, and then we'll throw a couple of compute hosts down here on the bottom. All right. This works fine with spine leaf, spline, three-tier hierarchy, layer 2 fabric. Doesn't really matter what network technology you're using. NSX will overlay onto any of those. Doesn't matter what your network vendor is either, vendor agnostic. So we've got a basic network architecture set up here. Let's go ahead and throw on our host down here a couple of VMs. So we'll create a couple of web VMs, right? Call this Web 1, Web 2, and I'm going to create those in logical space as well. There we go. All right. So normally, one of the things that we'll configure here in the network is a layer 2 adjacency, right? So these VMs have same IP address on the same subnet. They need to have some sort of layer 2 adjacency, right? So what we would typically do is go to the core. We would create a VLAN. Push that VLAN down to the distribution, push it down maybe to a top-of-rack switch, ultimately down to the host. From there, we would create a port group on the virtual distributed switch in the hypervisor, connect a VM to a port group, and now I've configured the physical infrastructure to provide that service, that layer 2 adjacency. Remember, we want to pull these services up out of the physical network and provide them in software. So what we're going to do, rather than creating a VLAN, is we're going to create a logical switch in vCenter. We'll call this our web logical switch. All right. When I create this web logical switch in vCenter, it's going to push that logical switch out to all of the ESX hosts in the environment that have been prepped with NSX. And it's going to create a local instance of that logical switch. All right, so you see here I've got my blue logical switch exists here on my ESX host, but it doesn't exist on the physical network. Right? I haven't gone through and configured a VLAN to back up this logical switch like I would with a port group. Instead, what we're going to do is we're going to use the VXLAN protocol. All right. So VXLAN, IETF standard, was submitted by VMware, Arista, Cisco, Red Hat, several companies in conjunction to create a layer 2 over layer 3 tunneling standard, which is what we're going to use here for NSX. So as part of this VXLAN protocol, I'm going to have what we call a VTEP, or a VXLAN tunnel endpoint. All right. Each host has one of these VTEPs. All right, so we're going to go ahead and include that VTEP here on the host. This is a kernel interface that exists in the hypervisor. And we're going to use this to tunnel our traffic across the physical network. So Web 1 wants to talk to Web 2. What does he do? He creates a standard layer 2 frame. Right? He puts it on his logical switch or his logical segment. That gets picked up by the VTEP. At this point, the VTEP is going to add a 50-byte VXLAN header. So I'm encapsulating that layer 2 frame. The new destination IP is going to be the IP address of the remote VTEP. So I don't have to extend a VLAN from host to host in order to allow this layer 2 communication. Right? I just need to be able to route from host to host. If they're on the same VLAN, great. If not, I just need IP communication from VTEP to VTEP, as well as a 1600-byte MTU. And I can route this layer 2 frame over my layer 3 infrastructure. When it arrives at the destination host, I'm going to remove that encapsulation and deliver the original layer 2 frame to Web 2. So if you look at what I've done, right, really quickly, I have taken layer 2 adjacency as a function of my physical network configuration, and I'm now doing that in software. Maybe I want to create another layer 2 segment, right? So if I've got some web servers, those tend to work well with app servers, right? So I create an app logical switch. All right, I'm going to create some app VMs here in my hypervisor. When I create that logical switch, it's also going to create the logical switch instance on these ESXi hosts. And now I've got a separate layer 2 network. These guys completely exist on different logical planes, right? There's no communication between web and app at this point. But app is going to use the same communication path to talk from app 1 to app 2 that web 1 and 2 do. So the next thing I'll probably want to do to allow these guys to communicate is enable routing. Right? So logically, I create a router that connects those two layer 2 segments. But what happens in the physical world is in the kernel of each ESXi host, I enable a routing module. So these are distributed services. Both my logical switching and logical routing services are distributed. They run in the ESXi kernel as a module there, and the work is actually performed in the kernel of the host. So in this case, web 1 wants to talk to app 1. What happens is it follows a pretty normal traffic pattern. Right, web 1 puts a packet on the wire, sends it to his default gateway. His default gateway routes it, puts it on the appropriate layer 2 segment, and then it can be delivered via layer 2 communication to app 1. In this case, since web 1 and app 1 are both on the same host, web 1 is going to put his layer 2 packet on the wire destined for his default gateway. Default gateway will route it, put it on the app logical switch, and that packet can be delivered to the app logical switch. So in this case, I never even traverse the physical network in order to go between hosts or between VMs on the same host, but on different subnets, on different layer 2 domains. Now, if I need to go web 1, app 2, same process. I'm going to send a packet to my local instance, my local routing instance, my local default gateway. Routing will always occur on the local host. So web 1 sends the packet to his default gateway. It's going to get routed, put on the appropriate layer 2 segment, picked up by the VTAP. Now I tunnel it across the infrastructure. When it arrives at host 2, it'll be put on the appropriate logical switch there and then delivered on to app 2. So now I've taken layer 2 functionality as well as layer 3. I'm providing that for my logical network design and software, and again, just using my underlying physical infrastructure as an underlay VXLAN transport network. So eventually, I'll probably want this network to talk to the physical world, right? So we're going to introduce our edge service gateway. Now the switching and routing, these were distributed kernel modules, right? They run on each host. This edge service gateway is actually a virtual appliance, so it lives on a host somewhere. I have to go to that host to get services. It doesn't exist everywhere. It's a centralized location. It's in a centralized location. But I can provide lots of services on here, right? So this guy can be a firewall. I can do NATing. He can be a load balancer. I can do layer 2, layer 3, SSL VPN, DHCP or DNS on here. So lots of functionality that I can enable. And I can create multiple of these, right? So I can have this guy here is maybe doing a firewall and routing and doing NATing. I can also create another one that exists here on this web logical switch that does load balancing for my web application. All right, these are just x86 virtual appliances, so they can really, you can create as many of them as you want, as many as you need. And then on the other end, I'm finally going to extend a VLAN out to a physical router somewhere. So this is my first physical device. Now over this link between the edge service gateway appliance and the physical router, I'll run some routing protocols. Typically BGP or OSPF. Also support ISIS here. And then I'll also run those protocols here between my distributed logical router and my edge service gateway. So again, BGP or OSPF. All right. So now I can advertise my logical networks, my NSX networks, out to the rest of my infrastructure. My users know how to get into my web application. and vice versa. I can advertise external networks into NSX, or I can just make this all a stub area if I want, just inject a default route, and I can use that to get out to the physical world. So the next thing we'll talk about really quickly is security, right? So I just told you, hey, Web1 and App1 can exist on the same host, and they can talk to each other without ever traversing the physical network, which sounds great until you start to think about the potential security implications, right? So usually, in the real world, we'll hang a firewall off of our core. This can be used for north-south access. This can be used as a default gateway for our VLANs if we want to put stateful packet inspection in between the different VLANs. I could have multiple security contexts in here, right? So lots of things I can do, but the problem with this security architecture is that I actually have to go seek out that firewall in order to get security services. The problem with that is that everywhere that a packet can propagate before it hits that firewall is a potential attack plane. Right? So in a traditional network, if I'm using a default gateway as on my firewall, then all of the VMs within that VLAN are going to be open to an attack within that VLAN. NSX works a little bit differently. So we're also going to use a distributed module here. We call it our distributed firewall. It is going to run on every host, but it's going to be configured centrally through vCenter. Right? So I'll have a vCenter server. Right? He's going to talk to my NSX manager. And on that NSX manager, I run my firewall. So I'll configure this firewall here centrally, but it gets implemented on the VNIC of every hypervisor in my NSX environment. All right. So I have a full line rate stateful firewall now sitting in front of every VM in the environment, implemented in the kernel of the host. What's more is I can start to get a little more object-based with my security creation. So I can do layer 2, layer 3, MAC address, IP addresses, and TCP port numbers if I want to, just use IP sets or IP rules. But I also have the ability to create groups or use vCenter objects. So in this case, I've got a web logical switch or an app logical switch. I've got a load balancer here, so I'm going to create a firewall rule set real quick that will allow communication to my 3-tier web app. So we'll say anyone can get to my load balancer here, right? And the virtual IP of my web application on 443. Let's say that we've configured our load balancer to SNAT, the source address. So from that SNAT address, I'm going to allow traffic to my web logical switch. And we'll say that I've done SSL offload here, and I'm just talking port 80 to my web servers. We'll let the web logical switch talk to the app logical switch on 8080. App logical switch to the not pictured here database logical switch 1433, and then we're going to deny anything after that. So I've got a firewall rule set here that allows external users to come in, hit my load balancer VIP, load balancer to talk to web, web to app, app to, not pictured here, database. But you'll notice, app can't initiate a connection to web, web can't talk to database, so on and so forth. So a couple things that are nice about this, right? Let's say, first off, that I want to bring up a new web server, right? So we're going to add another host here. And we're going to create Web 3. And of course, we've got a VTEP that this logical switch sits behind. So what just happened, right? Because I'm using object-based security, whenever I create Web 3 here, right, he automatically assumes the security posture of the object that he's associated with, the web logical switch. Right? So just by coming up and being connected to a certain layer 2 segment, he automatically inherits that security policy at the VNIC. I don't have to go back and change my firewall rule set. I manage who the rules get applied to based on this group membership. All right? So now, let's say that something happens and we come in and we get attacked here. We get some malware on one of our web servers. So how does this malware typically propagate? The very first thing it's going to do is try and propagate to its neighbors on its VLAN. Right? In a traditional VLAN-based network, there's nothing to stop that propagation from happening east-west within the layer 2 domain. We talked about that earlier with the firewall placement. However, now, because we're running this line rate stateful firewall on every VNIC, I actually stop that layer 2 propagation because there's no rule allowing web-to-web communication. Web 1, 2, and 3 can't talk to each other. There's no need for these guys to communicate. So when Web 3, in this case, does get infected, we'll stop that propagation from happening east-west here in the VNIC of the kernel of the hypervisor. Another big use case for NSX, a lot of customers like to use it for multi-data center, cross vCenter, maybe DR, active data center scenarios. So we'll talk about that real quick. So let's say this is data center 1, right? And I'll have a link over here to core device, distribution layer, and then we'll stick a host over here at data center number 2. And let's say we want a vMotion Web 3 over to that remote data center. All right. So we're going to go ahead and vMotion this guy. All right, so he exists over in data center 2 now, but I haven't mentioned using any kind of proprietary protocols to extend VLANs between data centers, right? Basically because with NSX we don't need it, all right? So what did I say we need earlier for communication between host 1 and 2, or for the logical networks that reside on host 1 and 2? We need IP connectivity from the VTEPs, and we need a 1600 byte MTU. So as long as you're providing 1600 byte MTU and IP connectivity between VTEPs, between data center 1 and data center 2, I'm going to use VXLAN as the transport, and I'm going to tunnel this layer 2 traffic across the IP network, even if those are different, geographically different, diverse data centers. So I can now extend my layer 2 segments, my layer 2 adjacency between data center 1 and data center 2, not by stretching VLANs across this geographic distance, but just by extending the overlay network between different data centers and still relying on this underlying IP fabric to be my transport for my VXLAN overlay. So lots of flexibility there when it comes to active data centers, failover, DR scenarios. Okay, so we're going to expand a little bit on what we talked about in the NSX-101. We'll talk about kind of multi-tenancy, right? How we can enable these different tenant environments within an NSX logical network. So the nice thing about this is, right, that my whole application environment, right? So my web servers, my app servers, again, my not pictured here database server, the networks, the layer 2 segments that support those, right? The router that they all connect to, the load balancer that I use to spray traffic across my web servers, they're all logical components, right? So what I can actually do now is take and essentially snapshot this, right? Along with the firewall rules that enable and limit the communication within this environment, but I can snapshot it, right? It's just it's just a logical construct now within vSphere. And if I can snapshot it, then I can faithfully reproduce it, right? So I can back it up, I can deploy it over and over and over, right? So if I'm a service provider and I'm providing tenant environments for multiple different customers, right? I can segment all of those off into their own tenants. Maybe if I'm doing application development, I want to do a test dev prod, right? I can create different tenant environments for that as well. And then I just link those in through this edge service gateway. So I'll use this edge service gateway to route between different tenant environments, also to provide firewall policy between those tenant environments, to NAT between those tenant environments, so on and so forth, right? So this becomes pretty useful in that, let's take an example where I'm doing kind of a test dev prod, right? So if I have an edge service gateway, and we're going to connect him down to different tenant environments that also sit behind edge service gateways, right? So here's tenant 1, tenant 2, tenant 3, and then I've got, my logical networks inside here that are exact replicas. Really, if I want to, I can just take one environment, snapshot it, and then deploy it into a couple of different tenant environments. So let's say here's my prod, right? So I'm actually routing traffic in and out of my prod environment here. These are test and dev, so I'm going to NAT here on this edge gateway. This allows me to use the same overlapping IP address, right, but to only route to one active production environment. So I go through my development lifecycle. I move that application into a test environment, a QA environment. I'm ready to promote it. So rather than necessarily promoting the application, if this guy's ready, right, I can just change the way I do this. I kill routing over here. I start routing like that, and then I just move my NATs here, and my QA environment or my test acceptance environment, right, has now become prod. If something doesn't happen right, I want to fail it back over, no big deal. I just start routing this way, move my NAT back, and I've reverted to my old environment. I can do that in a matter of minutes rather than the long rollback that it would normally take to roll an application back to its previous state. Same thing if I'm doing different tenant environments, right? So here's customer or tenant 1, tenant 2, tenant 3. Maybe I use overlapping IP addresses, maybe I don't. But I can provide these environments along with a base firewall rule set, right, or a base security posture that attaches not just within the environment, but also applies to north-south traffic outside of the environment through this edge service gateway. And then I can give my tenants access to go in here and modify their environment as they see fit. So this is all very simple, right? It's very easy to do in NSX. It really kind of becomes inherent in the product, whereas trying to create these different environments within a physical network, like we're talking about over here, I'm probably going to have multiple different security contexts, different VRFs to handle routing within different environments, especially if I want to have overlapping IPs. Rather than configuring my infrastructure to try and support something like this, which can be done, right? But it's not easy, and it's definitely susceptible to errors, whereby a mistake on one tenant environment can cause problems across the rest of them. Since these are all logical constructs, I really just build them behind a different edge service gateway without the risk of affecting these other tenants. So beyond that, we'll talk a little bit more about security policy and service insertion. So going to erase my tenant environments here. And let's take one of our hosts. Right? Could be any one of them. And we'll say that one of our PCI web servers lives on that host. All right. So I've got my host, I've got my web server, and I've got my VNIC plugged here into my virtual distributed switch. Now, if I want to bring in a third-party service provider, right, so I talked about our distributed firewall being layer 2 through 4 stateful packet inspection, but what if I want layer 7 inspection on east-west traffic within the data center? All right, so we've got a lot of different partners that we partner with. One of those would be Palo Alto. So basically what I'm going to do is I'm going to bring up a panorama box. I'll register that with NSX Manager. Right? Those same objects that I used from vCenter in NSX to create these security profiles, right, on my firewall, I'm going to pass those objects over to Panorama. And now I can go into my Palo Alto device and I can configure my layer 7 policy using those same object groups that I use to create my distributed firewall policy. That policy gets passed back down to NSX. NSX is going to spin up a virtual edition of that Palo Alto device here on the host. Right? So in this case, maybe we're talking about host 1 down here. And now I can start to chain services in the VNIC. Right? So the first thing I do maybe is a distributed firewall here. So a packet comes out of the VM. He'll pass through that distributed firewall. Is this packet allowed or not? Yes or no. If it passes, maybe the next thing I want to do is look at that packet and say, do I need layer 7 inspection? And I might create a policy in Panorama that says, For my PCI web server, if it's SSL encrypted traffic, I'm not too worried about it. Go ahead and allow it to pass. I can pass PCI data over an SSL encrypted packet. However, if it's port 80, and it passes the firewall rule set, maybe I need to redirect that over to Panorama, right? And check and make sure that there's no PCI data contained in the payload of this unencrypted packet. If there is, I can drop it in Panorama, right? Or I can send it right back and allow that packet to pass. So even down here now, essentially in the hypervisor of my ESX hosts, I'm inserting layer 7 security as well. Other services I can insert in here into the VNIC, everything from AV endpoint protection, malware detection, load balancing, lots of different services that I can start to insert here in the VNIC, bringing them down into the hypervisor closest to the application workloads.